Einstein ran to science when life broke. Today I ran to code, books, and the gym. Here's day 24.
Started in class, fought bugs, lost a trade, hidden books, learned metrics, climbed Spanish, finished at the gym tower. Day 24.
I opened day 24 the way I always do, with DSA, and today was a 2-for-1, Kosaraju and Tarjan. Both algorithms find strongly connected components in a directed graph, groups of nodes where every node can reach every other node. Kosaraju is the clean, two-pass approach. First, run DFS to record finish times, which reflect how deep each node's reachability goes. Then reverse all edges in the graph. In the second pass, run DFS in descending finish time order. Each DFS now produces exactly one SCC. Reversing edges turns outgoing paths between components into incoming ones, so starting from the latest finished node prevents leakage into other components. It runs in O, V plus E time, uses extra memory for the reversed graph, and is easy to reason about and implement correctly. Tarjan is the single-pass version. One DFS assigns each node an ID, tracks low-link values, and uses a stack. When a node's ID equals its low-link, all nodes on the stack up to that point form one SCC. It avoids graph reversal and runs fully in place. But the logic is more delicate and harder to debug. Both algorithms work only on directed graphs and only for SCCs. They don't directly find bridges or articulation points, and on very large graphs, recursive DFS can overflow the stack unless implemented iteratively. Straight from lecture to battle mode. I did this strongly connected components problem on Geeks for Geeks. I explain my exact flow so viewers who code along won't get stuck. Build the adjacency list, run the ordering DFS to collect finish times, reverse the graph, then collect components in the reverse pass, classic Kosaraju. I call out the tiny bugs that waste contest minutes, whether the input is 0-based or 1-based, marking visited nodes properly on the reverse pass, and in Tarjan, making absolutely sure you only pop a component when low-link equals discovery ID. I say it out loud, so you don't have to learn those lessons by failing test cases at 2 a.m. Next up, leak code, critical connections in a network. I explain the problem plainly. You're given an undirected connected network, and you must return the edges that are critical. Remove one, and the network splits. The solution lives in low-link values for undirected graphs. Run DFS, stamp discovery times, compute low values from subtrees and back edges, and flag an edge, U, V, as a bridge when low disk, U, meaning V subtree can't reach you or any of U's ancestors without that edge. I walk through the DFS carefully on camera, show how to skip the parent edge, update low, U after exploring a neighbor, and why this runs in O, V plus E. It's neat, efficient, and exactly the kind of problem that makes you feel like you leveled up. Trading came next, and, as usual, the market didn't bother reading my plan. I opened TradingView, marked up gold, and built a bearish bias based on structure that matched my rules. The setup was clean, defined entry, clear stop, control position size. No impulse, just execution. Price moved in my favor at first, enough to validate the idea. Then momentum flipped. Liquidity thinned inside my zone, price snapped back, and one sharp move later my level was swept, about $54 down, just over 1% of the account. The session was messy overall. Choppy price action, whipsaws, fake breaks, and zones that looked good on paper but delivered no follow-through. That kind of market punishes both patience and impatience. I break down the trade afterward, what structure I saw, why the short made sense, and where execution could have been better. In hindsight, the trigger needed to be tighter, or the trade should have been skipped. Losses like this sting, but they teach fast. The lesson was simple. When structure is unclear, tighten the trigger, or stay out. Discipline matters more than capital. After that spike of adrenaline, the mood shifts to something quieter. Reading Walter Isaacson's Einstein. I'm deep into the divorce chapter, and it's heavy in a way equations never are. Einstein's son needs constant care. The family fractures widen. The marriage collapses. And yet, even as relationships erode, Einstein continues to support his family financially, carrying responsibility without the closeness that once justified it. What stands out is how Isaacson frames Einstein's response. Again and again, he retreats into physics, not as an escape, but as a refuge. While his personal life unravels, the universe remains orderly, solvable, and honest. In the midst of emotional chaos, equations become a kind of shelter. It's a heartbreaking section, but also a humanizing one. The same mind that reshaped space and time struggled with intimacy, responsibility, and family. Genius didn't exempt him from pain, it just gave him a different place to hide from it. Reading this is a quiet reminder. Brilliance and messiness often coexist. Even the brightest minds live complicated, imperfect lives, and sometimes the work is the only place that makes sense. Machine learning came next by StatQuest, Logistic Regression, Part 3. This session clarified an important shift in thinking. In linear regression, our superscript 2 measures how much of the variance in the output is explained by the model. Logistic regression doesn't work that way because the output is probabilistic. Instead, it uses pseudo R-squared measures like McFadden's, which compare model likelihoods. These values are relative, not absolute. They tell you whether one model explains the data better than another, not whether a single model is good on its own. P-values fit into that same framework. A p-value asks a very specific question. Assuming the model is correct, is this coefficient meaningfully different from 0, or could it be random noise? It doesn't prove the model is right. It just tells you whether a variable is statistically contributing information. Goodness of fit, often framed through G-statistics or likelihood-based tests, was the other mental unlock. In logistic models, G measures how well the predicted probabilities align with the observed outcomes. Lower mismatch means better fit, but again, the focus is on comparison, not perfection. These metrics help decide whether adding variables improves the model or just adds complexity. This was a session that demanded pausing and rewinding, not because it was hard, but because it was precise. Gemini's note-taking condensed everything into clear, bite-sized steps. By the end, logistic regression felt less like a formula and more like a structured way to think about uncertainty and decision-making. Quant prep followed, and I hit number systems: rational, irrational, real, complex. I speak directly to the pain. Textbooks look like alphabet soup, but here's the practical bridge I drew for myself and for viewers. Complex numbers and these abstract number theory tools show up in real quant workflows, especially when you use Fourier transforms, characteristic functions, and FFT-based methods to price derivatives or accelerate option pricing algorithms. I give a quick, concrete example on camera. When pricing certain options, integrals become transforms, and complex arithmetic isn't optional. It's the language you use to make the math computable efficiently, stably, and at real-world scale. Once you see that, the symbols stop being pointless rules and start to look like tools built to solve actual financial problems. I closed out the brain work with language practice and the gym. Spanish streak, day 353. Today's module focused on talking about childhood in the past tense. Phrases like when I was a kid, and there was a small emotional hit practicing memory-based sentences after reading those earlier scenes about Einstein's kids. Different subjects, same theme: memory, time, and how the past lingers. I also mention climbing to the top of the app leaderboard. It's not a huge win, but it's tiny momentum, the kind that compounds quietly over time. No hacks, no shortcuts, just showing up daily until consistency starts doing the heavy lifting. Then it was push day at the gym. I lay out the routine clearly so anyone can follow along. 3 sets of incline barbell bench, 3 sets of flat bench, 3 sets of machine or cable flies to really target the lower chest. After that, shoulders, 3 sets of shoulder press, and 3 sets of machine lateral raises. I skipped rear delts because they were still sore from back day, and that choice matters. Knowing when not to train is just as important as knowing when to push. That's recovery over ego, training for progress, not for validation.
The network awakens. Intelligence takes form. Undegreed. The signature remains.